actually be starting section 5.2, and this is discussing one-to-one functions and inverse functions. We're going to start off today just talking about one-to-one functions. And the definition you can see here is on screen. Here's the important part. As long as I pick an x1 and an x2 that are not equal to each other, then I should have this relationship. So how can we use this effectively? Well, using it in this form is not the easiest thing to do, because there's a lot of instances where x1 would not equal x2, and there are a lot of instances where f of x1 will not equal f of x2. That doesn't mean that all of them are that. So generally, we look at if f of x1 equals f of x2 implies that x1 equals x2, then this means that we have a 1, 2, 1 function. Okay. And this is the definition that we will use when we are actually trying to determine some of the if some of the items are one-to-one or not, but we will look at that as we get to it. For now, let's kind of get a picture representation. Let's say that this is the domain of f. So, domain of f. And there are a bunch of different points in said domain. And over here I have the range of f. And there are several values over here. As long as we have a situation where each of these goes to exactly one other item, and vice versa, however you want to arrange these. As long as we have a situation where each of these is going to a unique, or going to one value because we need that for it to be a function, and each of these only has one x value associated with it, that means that this is a 1, 2, 1 relationship, or one-to-one correspondence. And there's a lot of cool stuff that we can do with one-to-one correspondence, which I will show you when we get back, one of the cooler things. But let's move on. We're going to look at two functions, even though only one's written up here. Is this a one-to-one relationship? Well, 1 goes to 5. 2 goes to 8. 3 goes to 11. And 4 goes to 14. And all of those are going to unique values, and all of these over here only have one x value associated with it. So this function is one-to-one. Well, let's look at this. Let's say person to model car. So, for example, Dr. Kellum drives a Accent. Is there anybody else in the world that drives an Accent? I am assuming the answer is yes. And since we have this particular setup, this cannot be a one-to-one function. Now, there are ways to get around this, and actually you are familiar with some of them simply by, instead of asking for model car, we could ask for VIN. So we could ask for the vehicle identification number, which is unique to the car. So in this case, there is no one that shares my VIN for my Accent, even though there might be many people who share the fact that they drive an Accent. So understanding that the situation can be manipulated to give us a value that is one-to-one is something that actually becomes important later. Let's look at this, the horizontal line test. Essentially, this is the exact same thing as the vertical line test, except we're talking about horizontal lines. So if our horizontal line touches more than one point on the graph, it's not one-to-one. Otherwise, it is one-to-one. So this actually gives us a lot of versatility if we're looking at a graph. For example, if I see these two graphs, well, I know pretty quickly that, yes, this does indeed cross more than one point, even though at the very end my hand trembled and I lost it. Did it again. Regardless, you're seeing what I'm trying to get at. This one, however, it is not the case. No matter where I draw my horizontal line, no matter where I draw this line, I'm only going to touch one part of the graph. So what we have here is this is not one-to-one, whereas this is one-to-one. So there is a way that we can actually instantly know if a function will pass the horizontal line test. And that is, we can ask ourselves the question, is the function always increasing? Or decreasing? If the answer is yes, it is always increasing, like this graph is, then it is one-to-one. So the line y equals negative 2x is one-to-one. It's always decreasing. The line y equals 1/3 x is one-to-one. It is always increasing. y equals x cubed is 1 to 1. It is always increasing. Y equals x squared is not 1 to 1. Sometimes it increases, sometimes it decreases. This is going to have a lot of ramifications in our next video. But until then, stay safe, and I will see you in the next video.